Hello, welcome to this video. Here we're going to talk about a function that takes in a string or a list of characters and returns whether or not that string is an anagram of a palindrome. So to review, I've made videos on this, both anagrams and palindromes separately. Palindrome is just a word that's the same forward as it is backwards. So ABBA is the same as ABBA, and so on for these. An anagram is just a rearrangement of another word, so you just take all the characters in that word, permute them some way, and all those permutations are an anagram. I made a video about that. Okay, so how do we figure this out? Well, we can just look at every permutation of our word and check if that is a palindrome. That would be like a good brute force way to do it. Not very efficient, but I'll show it anyway. So this is from a previous video. You can go to GitHub or watch the video to see that. And this is also from a previous video. I had many permutation functions. I'm just choosing the first one for convenience. So for every permutation of this string, if it's a palindrome, return true, else return false. So we have to convert this string to a list because the perm1 function only accepts lists. So prints, let's hope this works. Yes, it's true. Let's, hopefully this prints false. Good, because that's not a palindrome. That is. Okay, so this correctly checks if something's a palindrome, but we're not looking for palindromes, we're looking for anagrams of palindromes. So let's just rearrange this. Yes, because that is one of the permutations. So generating every permutation takes a long time for really long strings. So let's look at these strings a little more to see if we can see a pattern. Okay, so if we sort this, we're going to get A, A, B. So there's two A's, there's one B. If we sort that, we're going to get A, A, B, B. That's fine. Here's another one. So what you may notice is that when you sort these, there seem to always be two occurrences of everything except maybe one thing. And that one thing has to occur in the center here. So if we also had C's on the outside, that's still a palindrome, but now we have 3 of something. Let's try putting them on the outside again. Now we have 5. So it seems like it would be logical to say if this is just an odd number, if the count is odd, that's okay for one character. Otherwise, due to the symmetry of left being equal to right, that needs to be a 2 count, or it doesn't. maybe we do that. Then we'd have 4. Let's put A's in there. Then we'd have 6. Okay, so 2, 4, 6. Those are just even numbers. The B's are still even. We can change that. 2, 4, 6. Okay, so I'm going to go ahead and step out on a limb and say that the general rule should be every character except maybe one should have an even count. And then you can allow one character to have an odd count. So it can have 0 also if the actual number of characters in the string is even and not odd. So like that. So the counts are 2 of those, and then nothing. And that's fine. So is Anna of Pal 2? Okay, so for this we're going to need a little bit of help from our friend default dictionary. And we're going to make the values integers because we're just going to be counting the occurrences of all the letters that come in. So for each character in the string, increment that count by 1. I'm going to set the number of odd to be 0, and then we're going to iterate over all the key value pairs in this dictionary, and we're going to say if the value mod 2 doesn't equal 0, then it is odd, and we're going to increment the number of odd counts we have. And then at the end we're just going to ask if the number of oddly occurring characters is greater than 1, then this is not an anagram of a palindrome. Otherwise return true. So this can be 1 or 0. So here it's 1, here it's 0. That's good. Let's see if it matches. Taking a long time to load there. Not exactly sure why. Let's try that again. Oh my. Ah. I left a really long string in there. Okay. So for this reasonably sized string, which is AABB, yeah, I just demonstrated exactly why you should never use this first function. Alright, you should always use the second one. Those matched. So those match. But these are all palindromes as they come. So let's try to put this C somewhere else. Yes. Yes, if we arrange this, it is a palindrome. So let's just take out a B. That way we have the C has an odd count, and the B has an odd count. False. Alright. It appears this algorithm works.